Good afternoon, everybody, and thank you for making some time to come to this second informational meeting on the wild rice sulfate standard. My name is Dana Vanderbosch. I'm the Assistant Commissioner for Water Policy and Agriculture here at the NPCA, and I'm happy to kick off this second meeting and begin our presentation. So if we can go to the next slide, please. So today's meeting is really a follow-up to, oops, I think we lost our presentation.
Sorry about that. Inevitable technical difficulties. Okay.
There we go. Perfect. Today's meeting, again, as I said, is really a follow-up from our May 24th informational meeting. So this is the second in the series. And at that initial sulfate informational meeting, we talked about the why and the how of implementing the wild rice sulfate standard. So at this particular meeting, what we're going to be talking about, at that previous May 24th meeting, we talked about the sulfate water quality standard. We talked about where that standard applies, what waters it applies on. We talked about effluent monitoring and how the NPCA will determine if effluent limits are needed. If you missed that presentation, we did record it, and it's available on our website. You can either find it at the web address that is on this screen, or maybe an easier way to do it would be to go to the NPCA's main website and simply search on wild rice in the search engine there. And it should take you to the page where we have the presentation listed. Just want to let you all know what you should see on your own screen, and that is that this particular presentation is also being recorded. We are going to post this presentation on that same website in a few days. And for today's presentation, what we're going to be walking through is really options. If you've conducted sulfate monitoring and the analysis of the data shows that your facility needs a sulfate limit, then we'll walk through the options that are available to you. One of those options is a tool called a site-specific standard, and we'll describe in more detail what that tool is, what that option is, and how to request a site-specific standard if you'd like to do that. And then we'll end the presentation by describing some other meetings where we're also going to be available to talk to you about sulfate and the water quality standard. And we are planning a final informational meeting on that. So the logistics for today, we still have people coming into the lobby and being let into the meeting. So there are a lot of attendees. You do have access to the chat function, and if you have questions throughout the presentation, we do encourage you to put those questions in the chat function. One of the things that we did in the previous presentation, and we're going to do again today, is at various different intervals throughout the meeting, we are going to just pause and see if there are some questions that we can just answer for you kind of on the fly. If we have many questions, it may be we may run out of time and we may not be able to get to all of your questions, but we'll try to answer questions as we're able to. When we come back for our final informational meeting, if there are questions that we haven't gotten to, then we will strive to answer them at that final informational meeting. So with that, I think we can go to the next slide, and I'm going to pass the mic over to Steve Weiss. He's our effluent limit unit supervisor, and he's going to talk about permitting options if your facility receives a sulfate limit and you can't comply with that limit immediately.
Good afternoon. As mentioned, I'm Steve Weiss, a supervisor effluent limits unit, and I'll be talking about permitting options if you can't comply with that final water quality based effluent limit for a wild rice sulfate limit. And primarily this is going to be schedules of compliance and variances. So next slide, please. So compliance schedules. The compliance schedule is the most common and tried and true option used when permittees are unable to obtain compliance with a final water quality based effluent limit at permit issuance. Or in some situations, perhaps they can comply now, but they won't be able to once a facility is operating at full design flow. The compliance schedule gives permittees time to conduct background evaluations, work with known sources, identify possible sources, troubleshoot current operations, evaluate currently used chemicals to determine if changes in chemical use could be made, and other reduction opportunities. The length will vary. There's no standard amount of time. NPCA permit writers will send a new limits notification letter to the permittee notifying them in writing of their new limits, and the permittee then needs to respond to whether they can meet the limit or whether they can meet the limit or not. If they cannot, the letter includes what information is needed from the permittee, including how much time the permittee has determined that they'll need in order to comply with that new limit. The NPCA will work with the permittee to further develop a compliance schedule based upon the needs and the situation, and will discuss the appropriate amount of time. And if the amount of time supports compliance, as soon as possible, which is the term cited in federal regulations. Construction compliance schedules are similar to the standard compliance schedule above, except that these are used when there's known infrastructure upgrades needed and the permittee is ready to start construction work. A final issued permit with a construction compliance schedule is needed prior to construction work starting. This type of construction schedule still leads the permittee to compliance as soon as possible, whereas a voluntary construction schedule is commonly used for construction work that is not being driven by a new effluent limit. Next slide. So the variance is the other family of options. What is a variance? It's a Clean Water Act permitting tool that allows NPCA to address affordability, and it allows dischargers time to investigate compliance solutions. Next slide. The variance process involves three primary groups: permittees, the state or NPCA, and the federal EPA. So permittees need to provide a request, and we have an application form for this. We need economic information if eligibility is determined on the basis of affordability or feasibility. We also need source reduction or pollutant minimization information. We will need to know what activities could be done in the future to investigate sources or opportunities for reductions during the course of the variance. This will be used to build out the length of that variance. The state will receive the economics and will verify these. For municipal permits, much of this is publicly available and can be provided through the eligibility form, as it has been done for chloride variances in the past couple of years. Industrial permits will need to provide more permit-specific economic information. We will develop interim limits representing the highest attainable condition, which will be expressed in the upcoming permit if the variance is granted. And then we'll draft the permit, public notice the permit, and host a public meeting on the variance at least 45 days after the initiation of public notice. Additional justification is provided through the preliminary determination. All of this gets sent to EPA Region 5 in Chicago. We send this to EPA early to capture their comments in the final product. EPA will then scrutinize the economic justification, and they will review all parts in detail for consistency with federal regulations. Through all these steps, it's not unusual for there to be feedback loops and communication. Variances take time to develop, especially if it's for a pollutant without prior precedent. State and federal rules also require certain timeframes for public notice and review. Next slide. So let's talk about variance eligibility. Both Minnesota state rules and federal law are very similar. Both were revised during the same period and were developed consciously to minimize differences between them. So if you're meeting state rules, you'll also be meeting the federal rules. These rules provide 6 factors that could be used to justify variance eligibility. The 6th factor is almost always used. This factor discusses substantial and widespread negative economic and social impacts. For a municipality, this is usually determined by evaluating the cost to run wastewater through reverse osmosis. In 2018, we had Bolton & Menk and Bar Engineering do an alternatives analysis study on wastewater treatment for sulfate. It provided costs of various technologies. Those figures can be used to scale to community size and justify eligibility for a municipal variance. For an industry, this will be less formulaic. At the moment, we have guidance, a general request form that's not pollutant specific, and an eligibility calculator all available online. Next slide. Our analysis for individual variances closely follows federal economic guidance. Could you advance one more? For municipal wastewater facilities, affordability is evaluated through a primary and a secondary measure. For the primary affordability measure, if annual wastewater costs per household divided by median household income is less than 2%, the project is deemed affordable. If it's greater than 2%, it's not affordable. Advance. The secondary measure is defined more broadly by municipal economic health and widespread social and economic impacts in surrounding communities. Next slide. And you can advance this. There we go. EPA's Industrial Wastewater Affordability Index involves a primary and secondary measure too. The primary affordability measure involves profitability with and without pollution control. The secondary affordability measure might examine things like the level of industry competition, the likelihood of competitors facing similar pollution control costs, the willingness of consumers to pay more for the product, and other measures of widespread social and economic hardship in surrounding communities. We pulled a couple of quotes from the guidance manual to give you a window into some of EPA's insights. So, for example, it mentions arguably, as long as the applicant maintains positive earnings, it can afford to pay for pollution control. Also mentions that the structure, size, and financial health of the parent firm should also be considered. Next slide. There is a cost associated with applying for a variance. The hard cost is $10,850, and these costs are laid out in Minnesota state rules. There are also some soft costs that could be associated with facility planning or compiling the information necessary to determine eligibility and build the variance in the permit. In situations where treatment costs have not yet been determined, these could easily exceed $50,000 in consulting fees. The 2018 Municipal Wastewater Alternatives Analysis should alleviate this cost for municipal permittees. It's also worth mentioning that MPCA developed a streamlined variance eligibility tool for chloride that will be modified for sulfate, and we estimate that that probably took about $250,000 in staff costs to develop. Again, we intend to develop a streamlined application process. However, each individual variance still requires review and approval from EPA, and these interactions can take time. Next slide. So because individual variances do take so much time, we are exploring the development of a multi-discharger variance for wild rice sulfate. We don't have this yet, but we're looking into it. This would involve coverage over multiple permittees that are likely similar in nature and for the same pollutant. Multi-discharger variances, or MDVs, are used in other states like Wisconsin, Michigan, or Kansas, and there are others beyond that too. And they're set up to address all of the components of the existing state and federal law, like schedules of activities, interim limits, public meetings, etc. Often these key elements are written into state rules or incorporated by reference. Examples of those components, again, are schedules of compliance activities, methods for calculating the interim limit, and perhaps eligibility criteria. Next slide. So, in summary, it is really difficult to remove sulfate from water. Currently, the best technology to remove this is reverse osmosis. RO is very expensive to build and operate right now. We know that it's unaffordable for municipal wastewater plants. MPCA does not have the data to determine whether RO would be affordable for industries. And MPCA also recognizes the importance of the tools afforded by the Clean Water Act to assist permittees in meeting effluent limits. We're open to considering innovative options. And with this, I believe we've got a moment to pause. If there are questions, please write them in the chat. And I think we can take some time to address those. See one here from Abby Morissette. Will the streamlined variance process address industries as well as municipalities? likely will not. And I want to clarify that what we're doing with a streamlined application process would be similar to what we've done with chloride. We were able to simplify some of that because the economics behind the treatment is so similar among that group of permittees. Whereas for industries, the economics are quite a bit different and may not be publicly available. That was really the key to doing this for chloride and what we believe we'll be able to do for sulfate too. Are there other questions? Well, I think if you think of a question regarding variances or schedules of compliance, we may have some time at the end as well. But seeing no more right now, maybe we could move on to the second portion of our show.
That sounds good. Yeah, as Steve said, feel free to continue adding questions to the chat as necessary or as they arise. So good afternoon, everyone. My name is Megan Hempkin. I'm part of a team that's working on site-specific sulfate standards for MPCA. And today I'll be walking through some of the main points of the framework that we have developed for evaluating these site-specific sulfate standards. And just a side note, I've realized that instead of saying site-specific standard, we generally just kind of shorten it to site specifics. So as I'm giving the presentation, you'll hear me just saying site specifics. I mean site-specific standards. So what is a site-specific standard? A site-specific standard is appropriate when data demonstrate that in a specific water body, the beneficial use can be protected at a different pollutant concentration than the statewide or the ecoregional standard. It is applicable to a specific water body, and it is protective of a single designated use. A site-specific standard does constitute a full water quality standards action. So developing one of these site specifics is a substantial amount of work with years worth of data collection necessary and a rigorous and pretty time consuming application and review process through MPCA and through EPA. So the proposer would be taking on the work to develop these site specifics themselves, the resources, the costs, staff time, etc. And so, as I said, with these, with water quality standard actions, it requires a public notice, a public meeting, approval from PCA, and then also approval from EPA. Similar to a variance, as Steve mentioned, it's standard action, so it goes through full review process with EPA Region 5. Next slide. So how are these applications evaluated? There are two main components of our review, and these two pieces are intricately connected. It is the derivation of the proposed sulfate standard and how the applicant is demonstrating that the beneficial use will be protected and supported at the proposed standard with indicators that are, separate from sulfate or from the pollutant concentration. And most importantly, how these two are interconnected. So you can't just develop a sulfate standard threshold separately from understanding the wild rice in that water body. These two pieces are intricately connected. So PCA anticipates a number of these applications, and while reviewing the first few, we recognized that we needed a better means of defining this process for both those who choose to pursue an application and for ourselves to better review them. So we developed this framework that has been shared with you in preparation for this meeting and is available on our website. Next slide, please. So the goals of our framework were to first define the beneficial use and what constitutes supporting said use. So what metrics are necessary to describe and show that the wild rice is healthy or self-sustaining and productive? Secondly, we wanted to establish expectations for the applications for how an applicant can demonstrate the use is protected and how to relate that back to the proposed sulfate standard, and also for the review of agency staff to meet those expectations as well. Further, we aim to identify other informational goals and data requirements that should be satisfied prior to advancing a site-specific standard. Next slide, please. So the first goal, as I said, was to define what the beneficial use is and how an applicant could demonstrate the use will be protected. So we pulled out our rule language, which we have here in quotations. The use is when the sulfate standard is applied to a water body that has produced substantial wild rice or any wild rice, and so it is applicable to waters used for the production of wild rice during periods when the rice may be susceptible to damage by high sulfate levels. And additionally, the use we've defined as the harvest and use of grains from this plant serve as a food source for wildlife and for humans. So we've worked on translating the rule language into what does that look like on the ground in a water body? What metrics, what indicators can we actually use to represent these uses within a water body? So to be both productive and abundant enough to be a food source, we interpret the beneficial use to be a wild rice population that is self-sustaining and productive, or a healthy population. This means that the population needs to be regularly and observably present in the water body, not only in the seed bank, at levels that can sustain harvest by tribal nations and wildlife. It needs to be recurring annually or following the multi-year boom bust cycles, which I will describe in the next slide. And the population cannot be trending towards local extirpation. Next slide, please. So this graph shows long-term wild rice monitoring data on Kettle Lake collected by the 1854 Treaty Authority. The data here clearly show that wild rice productivity cycles, also known as boom-bust cycles, which are defined as a period of high biomass production, the boom, followed by a population crash, the bust, and then gradual recovery. These cycles often span 3 to 5 years and can occur due to delays in nutrient cycling or other environmental factors. As we said, these cycles can be 3 to 5 years, but they can also be much longer, or they could also not occur at all. It depends on the water body in question. But this is a good representation of what these boom bust cycles look in practice and what it looks like in a water body, and also further shows that there's no downward trend in wild rice abundance, which I said is one of the other factors that we're looking for. And just a sidebar, the red line signifies a change in their methodology for monitoring. So that's all. So tracking these cycles to better understand the productivity of wild rice in the water body, demonstrating that they are not trending in a negative direction, are critical components to showing that the wild rice population is being supported in the specific water body. Next slide, please. So I know there's a lot in these text bubbles, and I think they're also a little blurry. And we recognize that each of these text bubbles represent a number of significant interactions that are occurring in the environment that can impact wild rice. But the overall takeaway from this study, which was published in 2022, is that beyond understanding the cyclicity of specific wild rice populations, recent findings also demonstrate that long-term exposure to elevated sulfate can lead to a steady decline in the boom years and long-term abundance of a population. So these pollutant effects could drive populations toward local extirpation, but at the same time, you may still see some of the oscillating effects along the way due to that the natural cyclicity that we know that wild rice populations undergo. So this further demonstrates why we need to evaluate wild rice populations over longer periods of time to ensure protection of the use. Next slide, please. So since a site-specific application must demonstrate that the beneficial use will be protected at the proposed sulfate standard, the derivation of the sulfate threshold must illustrate the association between the surface water sulfate concentration with metrics that are tracking wild rice abundance and health. And the only approach known to make that direct connection is by applying the current ambient sulfate concentrations if the wild rice is demonstrated to be healthy and thus the beneficial use supported. So given what we know about wild rice health and some of the more recent literature on population dynamics, to support a demonstration that the beneficial use will be supported, we need significant wild rice health data and an analysis in any site-specific standard application. At a minimum, we need the current ambient sulfate concentrations along with these wild rice health data to show the linkage of those two pieces, as I've said. So wild rice data at the population scale of spatial extent and abundance is required, sulfate water column concentrations, and we are asking for 10 years or 2 boom bust cycles, whichever is less. Any less than that, we would consider insufficient to show how the wild rice population will be supported. We further recommend reviewing the Wild Rice Monitoring Handbook, published by the US Sea Grant, which was a collaborative effort between Sea Grant and tribal nations in the region. We also encourage applicants to evaluate options for monitoring wild rice health indicators at the individual plant scale and to collect supplemental chemical measurements within the sediment and the pore water. Next slide, please. Some further considerations for your application. We require applicants to explore multiple lines of evidence. Tracking a single metric is insufficient. We are requesting a review of recent scientific findings as well, knowing that the scientific community is continuing wild rice studies that are relevant to our work, evaluating these applications and your findings for your specific water body in light of the literature is important. Further, providing historical context is helpful, especially including any tribal ecological knowledge that is available and willing to be shared. That would be really helpful information to include in your application. We would also like an inclusion of examining regional baseline levels, as we know that sulfate concentrations in water bodies can vary greatly across the state. And lastly, we understand that wild rice can be impacted by a number of environmental factors, like hydrological changes, beavers, even storm events during the floating leaf stage. So addressing those, if relevant, is helpful contextual information for your application. Next slide, thank you. So just kind of reviewing the process here. The data collection process, as we've described, is a substantial lift, and we would expect the permittee to take on the work of developing a site-specific if they are interested. In the interim, though, MPCA will be reviewing permit limits according to the currently applicable standard, not a site-specific standard that is under development or in the review process. MPCA is not waiting for data collection to occur and the site-specific standard review process to be completed before putting limits into permits. MPCA will use all tools available to us in the Clean Water Act to craft permits, and these will be individual conversations held between the agency and individual permittees. So as I mentioned previously, a site-specific is a water quality standard action, requires a public notice period, public meeting, review and approval from EPA. It will have its own administrative process apart from the permit. We do not consider permit limits in our evaluation of a site-specific standard. The standard evaluation is focusing on the water body and what is an appropriate standard to protect the use within the water body. And as I said, does not include limit evaluations. But if a site-specific was later developed and approved by both MPCA and EPA, there are cases where the sulfate limit may be reevaluated at that point. And just to clarify, the limit reevaluation, if justified, would be performed in a separate process, and that permit public notice period, again, separate from the public notice period of the site-specific standard. So 2 separate administrative processes. All right, I think that's all I have to share. I think now if folks have questions, please put them in the chat. We have a team of staff available to answer questions. Again, if you have questions related to compliance schedules or variance as well, we can take those as well.
pause for a couple more seconds here to see if there's any questions about the site-specific standard framework, or frankly about the compliance, the other compliance tools that Steve mentioned earlier. A couple coming in. Do you want to address the first one?
Sure.
The question, let me just repeat the question. I assume that everyone can see it, but Abby is asking, how would MPCA determine whether a compliance schedule or a variance would be appropriate for a specific permittee?
Yeah, I think when we've dealt with this question with permittees in the past, it's been to some extent the discretion of the permittee. One part of that would be determining whether they could demonstrate the eligibility for the variance. If they could demonstrate eligibility for a variance, then there would be a choice. If there isn't a demonstration of eligibility, then it might be a slightly different situation.
And if we don't, if we
Yeah,
don't
go on.
fully answer the question, feel free to, put a follow-up question in the chat. Moving on to Brandon's question, he asks, are permits other than the ones that discharge into Class 4A water is going to be reviewed as well? Not sure if you mean, are they going to be discussed in this presentation, or are they going to be reviewed, during the permit reissuance process? So they're not going to be discussed here in this presentation today, but maybe Steve can address the whole issue of how all permit limits are considered at the time of reissuance.
Yes, so we will definitely be looking beyond just the immediate receiving water. Most permittees do not discharge directly into a wild rice water. They're discharging at some distance upstream of that, and so we will look all the way downstream from the location of that outfall point.
And Mark is asking, can you further discuss the other confounding factors related to site-specific standards? That might be a question from Megan.
Yeah. So what we're trying to kind of get at there is we understand that there are a number of environmental factors, changes that can impact wild rice's presence in a single year. For example, in the springtime, there's a stage of wild rice growth called the floating leaf stage. And it is when the roots aren't actually as strong as they are later in the season. And the wild rice plant is really just like floating on top of the water column. And so if there's a substantial storm, it can actually like basically flush away a lot of wild rice. Other confounding factors could be a beaver dam upstream that is changing the water levels in that water body, or other hydrological changes, droughts, flood years. And so it's just kind of a space to recognize if there are other things happening in the water body that could be impacting wild rice. Does that help answer your question, Scott or Robert, if there's anything else you'd like to add?
We also might want to just point out that the site-specific standard framework is on our wild rice webpage. And if you haven't read the whole framework, that might provide you with some more details too. So that would be a good place to go. Okay, Steve and Megan, you need to stay on camera because there's more questions for you. I think this one is for Megan too. Has there been consideration for situations where multiple permittees are upstream of only one wild rice producing water body? In other words, how might multiple permittees handle one water body for a site-specific standard? I'm thinking specifically of the Mississippi River segment downstream of the Twin Cities. So that's a great one to chat about. You're on mute.
Thank you. Yes, so we as an agency are actually evaluating a site-specific for the lower Mississippi. That would be a case where we are doing the data collection and the development of the site-specific ourselves. So that is a unique case. But yes, that is currently under development. We are collecting data this field season, actually. So yeah,
The next one is kind of more generally for, I think, our wastewater permitting program. If anyone has an answer to it, I ask that they kind of step in here. But the question is from Tom, and he says, in regards to using reverse osmosis treatment for sulfate removal, what do you recommend to do with a concentrated stream of sulfates? I think generally it is landfilled, but I don't know that for certain. So I'm going to open that up to our program staff to know if they know anything different.
Yeah, Scott Kaiser's here to be able to talk about that a little bit.
Hi, I'm Scott Kaiser. Can you hear me?
We can hear you. We can't see
Okay,
you.
good. Yeah, my camera is not showing me, but I am here.
Okay.
So I'm a wastewater engineer at the MPCA. And for reverse osmosis, the concentrate stream, which contains the briny sulfate, would need to be evaporated crystallized to remove the sulfate from the water. And then that sulfate would need to be disposed of. It could go to a landfill. Theoretically, it could also be beneficially reused, but that would require more investigation.
Corey is asking, when you look downstream for site with wild rice, will any boundary conditions be considered?
I can cover that. So one of the concepts that we're going to use when evaluating effluent limits is we're calling a boundary condition. So if there are areas that are between the outfall point and the downstream wild rice that consistently achieve concentrations on average less than the standard, so 10 milligrams per liter, that would function as a boundary condition. We don't have a lot of those examples throughout the state, but there are some.
Another question from Stephanie. I think this might be one for you, Megan. Is MPCA, oh wait, I'm sorry. This is from Mark. Is harvesting considered a confounding factor?
I can field this one. Hi, everyone. I'm Robert Dietz, a research scientist in the Water Quality Standards Unit, also a part of the team working on site-specific standards projects. It's an interesting question. I think we would think of harvesting not as a confounding factor so much, but as a relevant factor, a part of the totality of the localized environmental conditions that we want to know more about as much as we can, and that can have an impact on the water body. Harvesting activities could actually have a beneficial impact potentially on the wild rice populations, shedding more of the seeds into the water body, sinking through the water column, going to the sediment before being predated on by wildlife. And so that is something relevant to keep track of. Certainly, if there are harvest records available for that location, we would encourage you to explore and submit them, as that's also another way of looking at wild rice production, looking at how the population is essentially trending over time. So much encouraged to explore that if possible, but it isn't among the things that we were thinking of as confounding factors per se. Confounding factors would be more of the sort of factors that may potentially negatively impact the wild rice populations or stands within that site-specific environment other than sulfate and sulfide.
Thanks a lot, Robert. Another question for the site-specific standard team, is MPCA also developing a site-specific for the St. Louis River estuary?
We are not considering that at this time.
Vanessa is asking, could you expand a bit more on how the multi-discharge or variance might work?
I'll jump in on that. I can say that we're in the beginning process of looking into that and seeing how other states have used that concept for different types of pollutants. Most commonly in the Great Lakes area, multi-discharge or variances have been used for mercury, and like Michigan, Wisconsin, Ohio. I think the idea, again, is that you'd have a group of dischargers that would have common attributes and would require similar types of activities to be done over the course of that variance. And if that's the case, we might be able to gain some efficiencies by developing this. It's not clear precisely what might need to be done in a rulemaking or how we might go about that, but that's one of the major factors that we're looking into right now. So I wish I had more I could say about that, but I don't want to get too far ahead of our process of of developing that right now.
If we were to go through the multi-discharge or variance, I mean, that would require rulemaking, right? And the rulemaking process itself has a public engagement component to it, right?
Correct.
So there would, if we go down that pathway, you will definitely be invited to participate in some of our rulemaking conversations. Let's see, Scott is asking if the brine crystals are landfilled, what will prevent the crystals to be re-wetted and flow into leachate collection system, ultimately ending up at a wastewater plant? I don't know if anyone from our site-specific standard team can answer that. I think this is a very good question, and I don't know that I have a specific answer to your question here, Scott, but I will just observe that oftentimes when we have pollutants that we are identifying through our discharge, you know, what we're discharging into our waters, we do end up removing them and just moving them to other aspects of our environment. And so I think this is a common problem that we run into with several of the different pollutants that we're working with right now, and it's just a real challenge. But I'll see if Scott has anything more to add to this.
Yeah, this is Scott Kaiser again. Dana's entirely right. There are ways to stabilize sulfur molecules so that they don't leach out as much. They're still in development, and it requires even more energy than evaporation and crystallization. So this would certainly be a problem to think about, and that's why that's why we've determined that evaporation with crystallization at municipal wastewater treatment plants is unaffordable. This is just one of the problems with operating and funding a RO evaporation crystallization system at a municipal wastewater treatment plant.
And Tim is raising another question. He says our plant reverse osmosis process concentrate contains several constituents that cause the wastewater treatment facility problems in the effluent discharge, like bicarbonate and sulfate. How should we evaporate 200,000 gallons per day of concentrate water, especially in winter? You know, I don't think that we have answers to all of these questions. Again, I can pass the mic over to Scott and see if he has a response to this. I want to be clear. I don't think that we think that reverse osmosis is like the silver bullet that is going to solve all of our problems. But at this particular point in time, it's the most viable technology out there that can remove sulfate from discharge. I think this is a challenge that we are going to be facing societally, just like we are with PFAS and with chloride and with many other, you know, pollutants that we are sending into our state waters, where we know that we have a pollution problem and we know where it's coming from, but we don't necessarily know how to remove it and to put it somewhere else in our environment without it causing trouble elsewhere. And so one of the things that we are hoping to bring back to our final informational meeting is a component where we have a researcher come in and talk a little bit about other kinds of technologies that they're trying to develop that would remove sulfate in different ways. But developing innovative technologies is really a huge part of what we need to be driving towards if we're going to really remove sulfate from our discharge. With that, though, I'll pass it over to Scott and see if he has anything else to add.
That was a great job. I actually don't have anything else to add other than like the costs of RO with evaporation and crystallization. It's not even close to affordable. It's for municipal wastewater treatment plants. It's like outrageously affordable, like thousands of dollars a year in residential rates, and that's just never gonna happen, right? So, Tim, I would say I would say that your question is a good one in theory, but I don't know. I can't imagine a municipal wastewater plant using one of these technologies at their facility. It's just too much technology.
Right. And some of the technologies that are being explored are biological technology, similar to, you know, the microbes that we use to reduce phosphorus in wastewater. They're being considered for removing sulfate. We've also heard about using barite chloride to remove sulfate from wastewater, but each one of these technologies has, you know, they have other aspects to their use that also need to be considered. So there are several things that are in development that we're hoping we can bring to you so that we can all kind of learn together. But this really is a societal issue about how we advance this work. I'm not seeing other questions here, but I'm happy to pause for a moment and see if there are any other questions that might be coming in. Okay, we got a couple. Jason is asking, will recordings of this webinar be made publicly available? Yes, and that is part of my closing remarks, is that on our Wild Rice webpage, again, you can access it by going to the NPCA's webpage, and you can just type in Wild Rice in the search function. It'll pull you to our Wild Rice webpage. And this particular recording will be uploaded within a couple of days. So it will be available. And then Scott is asking, will the boundary limit condition that Steve referenced be similar to latent transport, in which immediate water quality conditions for dischargers not influence downstream impairments, thus excluded from sulfate limits? Take it away, Steve.
Yes. So Scott, I think our analysis will operate much in the way that you described there. We've got two factors happening, in some cases, some loss through transport, particularly if we have a downstream course going through wetlands that become anoxic. However, sulfate does, what we understand is sulfate is pretty conservative in flowing waters. And so there's dilution as well that may occur. But this is what we will use to evaluate, one of the principles we'll use to evaluate downstream impacts.
Okay, last call for questions. Okay. All right, well, let's just recap a little bit. And I do just want to point out that the sulfate water quality standard that we have here for Minnesota was promulgated 50 years ago. And we've simply not consistently applied this water quality standard or considered it in our permitting program. And so despite how difficult sulfate is to treat, we're committed to consistently implementing it throughout our permitting program starting now. And that's why we're more formally rolling out our plans for these informational meetings, because we're trying to, share some, basic or kind of foundational information as we kind of move into, the permitting aspects. We recognize that new limits can be a really big concern for permittees. We recognize that the difficulty of treating for this particular pollutant is very, very challenging. But we also believe that we're starting to see more attention being paid to developing other types of technology, and we're hoping that this will just continue forward. But I do want to reassure you that at the time your permit is reissued or modified, if you do receive a sulfate limit, which is not a for sure thing, but if your facility does receive a future limit, you know that you'll be working directly and closely with your permit writer and the permit team to figure out what the best option is for your company or for your community. And, as you heard today, the Clean Water Act does offer some options for dischargers. On the screen, what you see there is that over the summer, we're going to continue to reach out to permittees to answer your questions and to discuss implementation plans. So these are several different meetings that we have set up and that we're planning on going to. The municipal wastewater permit virtual meetings on the 27th and on August 8th, those meetings will, municipal permittees will receive invitations to those meetings, and so they can, but you can put them on your calendar now and just kind of hold the time if you want to be a part of it. We meet with a group called the Clean Water Discussion Group, which is a combination of some permittees and some wastewater stakeholders. We'll have discussion around sulfate implementation there. We're going to be present at the Minnesota Wastewater Operator Association meeting and available to talk about sulfate there. There's a quarterly mining meeting that happens with the mining sector, and so there's a meeting scheduled for August 9th. And we also have a meeting with our tribal nation partners that's scheduled for July 11th. So a number of little smaller group meetings. The municipal wastewater permit virtual meetings, I guess I should say, we're viewing those almost as office hours, where you can come into the meeting and you can ask your questions there. It'll be very informal. There's no presentation. It's just an opportunity for us to be able to have more conversation in a smaller group setting. So we're planning those throughout the month of July and kind of wrapping into early August. And then I think we can switch to the next slide. All right, about a week ago, I think it was probably a week ago, maybe even a week and a half ago, we released the site-specific standard framework on our Wild Rice webpage. And at that time, we directed people to there's a particular portal where we are accepting questions and comments. And that portal will be open until July 31st. And so if you have questions that are specific to the site-specific standard framework, you can go into that portal, you can share your comments, and those comments can be seen by others. And so the nice thing about that portal is that it's very transparent, and so people can see what others are, asking about or commenting on. We also are planning on posting to our Wild Rice webpage by July 14th, by mid-July, additional permitting details that you can read through. There is going to be a follow-up email that comes out with a great deal of detail, and I think we'll include some of the links to some of these other meetings. You can always submit questions or comments that you have to the email box that you see there, wastewater.permitting.npca. And even if the site-specific standard portal has closed, you can still make comments to the site-specific standard framework through that email box. So we will just continue to field questions and answer to comments that we receive through that mailbox. All of these questions and the rich conversation that we hope we're going to have in those smaller group settings will be used to kind of inform our final informational meeting, which is going to take place on September 6th. I don't think we've set a time for that. Once we do, we will send out an invitation to all of you so that you can come to that if you would like. And we'll just be walking through some of what we've heard, some of the questions we've received, and trying to provide some clarifying details for all of you. So that's the plan for that final email. Let's see, I think we did get, here's our contacts again. You can always, send comments to Suzanne, she's our municipal wastewater section manager, to Jeff, he's our industrial section manager, and to me, or again, to that general NPCA webpage, or I'm sorry, that general NPCA inbox. Are there any questions in the chat? I think Kate submitted an answer and Steve replied to it. Steve, is there anything else that you'd like to add before we close the meeting out?
Yeah, I was just writing back, suggesting that we will not be considering, we recognize that there are groundwater, areas of the state with groundwater that is significantly higher than 10 milligrams per liter, quite a bit higher. This will not be factored into the effluent limit analysis, other than knowing that we've got background concentrations that will go into what we call the reasonable potential portion of the limit analysis, but it won't be used to modify or make limits less restrictive necessarily. It won't modify the underlying water quality standard through the limit setting process.
All right, thank you very much, Steve. Good. Well, I hope we were able to answer at least some of your questions for today. And again, we are looking forward to continuing the conversation here as we go throughout the months of July and August. And we'll hopefully see you back here again on September 6th when we have our final informational meeting. Have a good afternoon, everyone, and thanks again for joining us.